Hello, everyone. So we have a nice probability problem from MATHCOUNTS chapter 1. So the question is asking the probability that a randomly selected integer from between 1 and 81 inclusive is equal to the product of two one-digit numbers. Okay, so we make sure we understand the question. It says we are going to choose two numbers between 1 to 81, and that number we chose, whatever number we choose, is gonna be equal to multiple of two one-digit numbers. Like if you have, let's say, two, it's two times one, that's okay. Like five is five times one is okay. So just to kind of see what's going on, maybe it's better to start like listing the numbers. Like if I start with one, two, like three, all of these integers, like until nine, even 10, is actually the numbers that we like because one is one times like one, so it says we select one integer, which is let's say one, that is product of one and one. So we could say when you multiply two one-digit numbers, which is one and one, you get multiple of one. So that is one of these numbers that we look for because they didn't say two different one-digit numbers, so it could be same two numbers. And then two is two times one, three is three times one. Anything in this range is okay. 10 is like five times two, so which is why that's also okay. But when you look at the next one, 11, 11 is like 11 times one, but 11 is not one digit. So which means 11 is a bad guy. And then 12 is okay because 3 times 4, like 14 is 2 times 7, 15 is 3 times 5, like 5, and 16 is a lot of different ways, 8 times 6, I mean 8 times 2 or 4 times 4. But 17 is also a bad guy, which is 17 times 1 because 17 is not one digit, so we can accept that. But based on this, the only numbers that doesn't look like nice numbers based on our definition of the nice is the prime numbers, right? That is larger than like 10 because it kind of makes sense since every prime number that is larger than 10 has a two divisors, like all the other ones as well, two divisors, but if your prime number is larger than 10, the one divisor is 1, the other divisor is itself, which is larger than 10. So which is what we don't want because we want to get two numbers, the product of two numbers that will be equal to product of two one-digit numbers equal to the given number. So which is why any number that is prime that is larger than 10 doesn't actually work for us. Okay, so which is why we can start listing the primes that is larger than 11. At this point, if you feel you understand the problem and you know what to do, pause the video and continue and see if you can finish the problem. So that's 11, like I can list 13, like 17, I have 19, like 23, 29. Just list every prime that we remember. And these are the really common primes that we actually need to remember up until 100. So which is why I kind of get those a bit faster. So if you cannot get this faster, so it's better to uh, kind of see those a bit more. So that will be 43 and 50, 53, 59, right? So we got 61, 67. But by the way, while you are rushing through writing those primes, it is better actually to slow a bit as well, just to not miss any of these numbers, because if you miss only one number, then your final answer will be different. So which is why we don't want to miss anything either. So we have now 71, we have 73, and 79. So let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So I think I missed one thing. So 17, 19, 23, 29. Let me double check. 31, 37, 41, 43, 47. I think, yeah, I think I missed 47. Okay, so which is why I highly recommend you not to rush that much. So we have now 18 primes in this case, 18 number that doesn't actually work. So, but other than this, maybe there are some other numbers that doesn't work either. So for example, if you take any of these numbers and multiply by some integers, let's say for 11, Like 22 is 2 times 11, but 11 is one of those two numbers that you multiply to get 22. So which is why 11 is not one digit, so 22 doesn't count either. Any multiple of 11 like 33, 44 has a 11 as a factor, so which is why it doesn't work because that's already two digit itself. So 55, 66, 77. So we have 1, 2, 3, 4, 5, 6 more numbers that doesn't work as well that we didn't count yet. And the same idea with 13. So any multiple of 13 like 26, like 39, 52, 65, and 78. So 1, 2, 3, 4, 5. So another five numbers doesn't work either. So that's just additional five number. And the next number is 17. So like 34, 3 times this will be 51, 4 times will be 68. So which is only three numbers because we just need the one all the way to the 81. So now next number is 19. If you multiply this by 2, you get 38. By 3, you got 57. If you multiply 5 by 4, you get 76, which is twice as much as this. And there is nothing more because it will be passing 81. So this is three more. And the next prime that we have 23. So we can have 46. And then 3 times will be 69. But after 69, there is nothing that is smaller than 81. So that's two more. And 23 and 29. Twice as much will be 58. Right? So if you multiply this by 3, that is larger than 81, so that just one more. And for 29, so we have now 31. So twice is 62, that's just one number. And the next number is 37. If you multiply by 2, you get 74, that's only one more number. And now we have 41. If you double that, you will get 82, which is not in this range, so we are done. So we have like 6, 5, which is 11, right? If you add this one, that's 14, 17, 20, 22. So we had 18 numbers already. So now we have 22 more. But if you feel this is the final number of like integer in between 1 to 81 that doesn't work, we are actually not correct with that because we do have some other numbers that is also multiple of some integers, like not just two integers, maybe three integers, that is gonna be what we don't want either. Like, for example, like if you take the like prime numbers like 2, 5, which is gonna be 10, right? So meaning that if you multiply 10 by like another prime numbers, for example, 5, so let me write what I'm trying to say. If you take 2, 5, and 5, which is 50, right? But 50 is a number, like you can multiply as product of two numbers. Should be like integer. That's one of those integer. But what we want is something that doesn't work, right? So like when you multiply like these numbers, like 2, 5, 5, that's 50. But in this case, like 50 is just the number that we got. You can just say 5 times 10. And 10 is one of these two numbers that we multiply, which is, 10 is not one digit. So, which is why this number is also one of the numbers that we shouldn't include our list. And this is not the only one. Any number like maybe 60, like 2 times, 3 times, like 5 times, 3 times 5. Also, like a 60, I can write 6 times 10. So 6 is one integer, which is one digit. 10 is another. So it doesn't work either. And the 70, the same thing. Like I can say 70 is like 2 times 5, which is 10. And multiply by 7, you get 70. That doesn't work either. And 80 doesn't work, but 75 doesn't work either because I can take 3, 5, 5. Like when you multiply 15 by 5, that's like, I mean, 15 by 7, that's 75. But one of those is 15, which is two-digit number. So that doesn't work. And if I take 80, like 80 is 2 times 2 times 2 times 2 times 5, which is 80. And then that is also another integer that has a like number in its like in product that is not one digit. So these are the only one that I seen. So if you check a little bit carefully, there is no such other numbers. So which is why we have 1, 2, 3, 4, 5 more numbers that is actually gonna be excluded from our list. So again, it's kind of tedious to find all of these, especially if you miss one of them, the whole thing is gonna change. So which is why that was a bit complicated. So I would say just slowly just take every case into like your like counting, so that will make sure that you are not gonna miss anything. So we have like 1822, which is 40, that's 45. So that means there are 45 numbers that doesn't work. Okay, so what we want is whatever else, right? So we have 81 numbers and 45 number doesn't work. So if you take the difference, you will get 36. So we are looking for the probability of getting a number that can be written as product of two one-digit numbers. So there are 36 of those. And of those, if you just like write the ratio, so that should be 36 over 81. And both numbers are divisible by 9, so that should be 4 over 9. And that is our final answer. So again, this was slightly challenging problem. And if you felt a bit struggling on this, so it's better to do a little bit more question about the casework counting. And that was the whole point about this problem. I'll see you in the next video.